Hello, my name is Sanjana Mendu, and today I will be presenting the research led by my colleague Haroon Rashid at the University of Virginia, titled Predicting Subjective Measures of Social Anxiety from Sparsely Collected Mobile Sensor Data. Social anxiety disorder is characterized by intense fear and avoidance of socially evaluative situations and affects 15 million adults in the United States. Mobile health technology has enabled researchers and clinicians to observe the manifestation of SAD in natural settings rather than only in clinical or lab-based ones. Apart from passive data, mHealth technologies can be used to understand real-time, naturalistic experiences via Ecological Momentary Assessment, a form of moment-to-moment data collection which allows for increased ecological validity while minimizing retrospective bias. As an important step towards understanding real-time experiences of social anxiety, we aim to test relationships between passive and self-reported social anxiety measures via smartphone technologies. Specifically, our first research question aims to address whether passive data can be used to predict daily self-reported experiences related to social anxiety. Using smartphone technology, we can capture fine-grained measures related to human behavior. However, in practice, we rarely get continuous, uninterrupted data from mobile devices due to a variety of factors, some of which are listed here. As a result, mobile sensor data often suffers from missingness, thus reducing the usability of machine learning algorithms researchers might otherwise apply. Thus, our second research question concerns how we might leverage passive data towards this prediction task despite missingness. To address these research questions, we use data collected during a 5-week mobile sensing and EMA monitoring study conducted at the University of Virginia. Our sample consisted of 80 young adults, all of whom experienced moderate to severe social anxiety symptoms as measured by a clinically validated instrument. During the baseline in-lab sessions, participants were asked to install MetricWire, a third-party application, on their personal smartphones. The MetricWire smartphone application passively recorded data from a wide array of built-in sensors listed here. To effectively characterize participants' daily behaviors in terms of these passive data streams, we collected a large number of day-level features. To mitigate issues of collinearity posed by the breadth of our feature space, we removed highly correlated features, denoted with an asterisk in the current table. The MetricWire app was also programmed to deliver 3-minute EMA surveys every day at 10 p.m. These surveys asked participants to self-report their daily experiences related to 7 different dimensions of social anxiety. This table shows the question phrasing and Likert scale responses corresponding to each of these subjective measures. To characterize the amount of missing data visually, we present the following heat map. To confirm the statistical imputation methods were viable for our dataset, we also ran Little's missing completely at random test and obtained an affirmatory p-value of 0.44. We used a total of 4 imputation methods in this analysis. Multiple imputation by chained equations, which is a multi-iteration method resulting in less bias. Matrix completion, an extension of matrix regularization methods. K-nearest neighbor, which uses a weighted average of the k-nearest data points. And finally, last observation carried forward, which simply replaces missing values with the last known observation. We opted for a regression-based predictive approach in this analysis because we were interested in getting more fine-grained output from our models and staying consistent with the Likert scales used in the EMA surveys. We evaluated a total of 7 different regression models, but only present results for the 4 listed here because they produce the least prediction error. We evaluated our model's performance using 5-fold cross-validation, and our performance metric was RMSE. Here we show the results of our predictive modeling without any imputed data to address our research question 1. Among the 3 prediction methods used, CatBoost performed consistently better than all of the other ones. We hypothesized the reason for this performance improvement are, firstly, that CatBoost uses all observations in the data set rather than throwing out observations with 1 or more missing values, and also because CatBoost handles missing values internally, thus resulting in more usable observations. Moving to our second research question, we present the results of our predictive modeling using 4 varieties of imputed data. Overall, every predictive model produced more accurate predictions when using the data imputed via matrix completion, with an RMSE decreasing as much as 22%. Further, MERF produced lower RMSE predictions than RF and CatBoost for all subjective measures, regardless of imputation technique used. To investigate the difference in model performance between different subjective measures, we plotted the results for two subjective measures for which our models performed well and poorly. Here we can see that the less erratically distributed social acceptance measure is more effectively characterized as compared with the more erratic social avoidance measure. Finally, we investigated the effect of individual differences in symptom severity on our model's predictions. First, we found that highly socially anxious participants reported a greater degree of variability in self-report measures over time. Second, we found that our models more accurately predicted subjective measures for less socially anxious participants due to this lower variability. This is consistent with the results presented on the previous slide. In summary, this research has yielded a number of important insights. First, shifting from naive single-iteration imputation methods towards more robust and complexity-preserving techniques is critical to advancing mobile sensing applications. Second, the relationship between passive data and self-report data varies from participant to participant. And finally, future work should focus on investigating the clinical implications of the subjective measures used in this study towards informing the development of personalized treatment for SAD. I'd like to extend a huge thank you to the researchers who pushed this work forward and to the audience for your time and attention. Thank you very much.